In part one of this subpart, or I should say part A, we got up to the point of actually measuring. Actually, we did a lot of talking and not a lot of doing. The purpose of this video is to complete the measurement of resistances. Now, by resistances, I don't just mean the resistors. What we're actually going to do is pull each tube individually. Then we will use the tube socket to test resistance, and we'll make a list of what we read. And then at the end, we'll compare that list to the schematic to see if there's anything that we found that might point to some trouble or require some replacement or whatever. And now, whenever I say that, it takes me back to my days as a teenager, or actually even a little before that, on Saturday afternoon watching that the great NBC program Victory at Sea. And for those of you that are not familiar with it, the narrator Leonard Graves, at the beginning of each episode, would introduce the episode with the theme, the great score from Richard Rodgers in the background, theme of the fast carriers. Graves would say, "And now, rings around a ball." Now, of course, I can't do Richard Rodgers or Leonard Graves, but, well, maybe I can.
Around a ball.
Boy, if that don't make you want to run right out and join the Navy, I don't know what is. But enough of the recruiting. And by the way, I was regular Army in Vietnam, so it just strikes a dagger to my heart to praise the Navy. But let's face it, all the guys did a great job there in World War II. Thank you for your service. The point of this video, though, is to show you how to go about doing resistance tests using the top of the chassis. Now, I point out that we still haven't powered this radio up, and we don't need to. What we're going to do is remove this tube. This is a 12SA7. We'll talk a little more about it at some point. I have written the number of the tube on here, and then put a piece of tape around it to hold it. Now, I'll be honest with you. Frankly, over the years, this tape, as the tube heats, it'll just disintegrate. So this is not a real good permanent solution. But the problem is that the number on this tube is virtually unreadable. So I wanted to make sure and mark it while I still knew what kind of tube it was. But the real point is we want to use the socket down here to do some tests. Now, I am going to be using a socket tester, or an extender, if you will. These are made by a company called Pomona, and they were available back in the day. They're getting scarcer. You don't need these. They make it convenient. The main reason I'm using these is because here you have the tube numbers. You probably can't see them, but when we zoom in a little bit, you'll be able to see them. We have the tube numbers, and that makes it a little easier for those that have trouble remembering, do you start with pin 1 on this side and go around this way, or do you start with pin 1 on this side and go around that way? Now, you can, of course, find that in any tube manual, but for our purposes, we're going to use one of these sockets to actually do our tests. Before I get too far into this, though, I do want to do one other thing, and that is to talk a little bit about these glass tubes. And when we get there, when you're removing the glass tubes, unlike the metal, now the metal tubes, you can pretty much pull on them anywhere. They're very solid. There's no issue there. The glass tubes, the thing you do not want to do is try to wiggle the glass. You want to get down here, hold of the base, okay? And some of these are very hard to get out, but do not try to use the glass to pull on them. What will happen is you'll break the seal between the base and the glass. And once you've done that, there is a very good chance that that you'll wind up pulling the glass out of the pins here. The glass is made and evacuated, and by the way, for those of you that might be interested in how this is done, not commercially, but a way to do it, you might look at Glass Slinger's YouTube videos. He actually makes vacuum tubes on his site. There also are a good number of nice YouTube videos by people like Phillips or Mullard and so on about how the tubes were actually commercially produced back in the day. But the main thing is, don't break this seal. Now, if for some reason you ever do break the seal, or maybe the radio came with a tube where the glass is already loose, don't use any of the regular glues here. The thing to use is go to an auto parts store and get windshield and glass sealer. This is a silicone-based sealer. This particular one happens to be made by Permatex, but there's other companies that make this too. This is designed to seal a windshield, and because it will take the heat of a Texas sun, it will last. If you try to use any ordinary glues here, especially polyacrylate glues, the so-called I forget what the trade name is for them, but at any rate, most glues that you use here not only will fail, but then they'll create a crusty barrier here that makes it hard when you realize you've made a mistake and you need to fill it. It's going to be hard to get this stuff in there. So start with the right thing, and if you need to seal one of these tubes, use the windshield and glass sealer. Where I'm going next is using an ohm meter, a multimeter, and this little $8 one is fine for this, though to be honest, an auto-ranging ohm meter is more convenient to use. But I'm going to measure the resistance between the chassis and each of the pins of these tubes. Now, I'm using an extender, one of these Pomona tube socket extenders, partly to make it easy to make contact with all the right pins, but you can do this from the underside of the chassis even if you don't have one of these these Pomona extenders, and you'll get exactly the same results. So I won't bore you with the whole process, but for example, what I'm doing is I am putting one lead on the chassis, doesn't really matter which one, and another lead on a pin. Take a look at that one. Well, that looks like it's 0 ohms. Let me try this one. Pardon the fumbling. I hadn't. You can tell I'm doing this in real time. Okay, that's 250K. That particular pin. This is the converter tube, but don't worry about what the tubes are. What I'm going to be doing is filling out a chart that for each tube, here's the chart that I'm going to be filling out. Over here is the tube. This is the SA7, the SK7, the Q7, 50L6, and 35Z5. And then this is the pin number 1 through 8. And so I'm going to fill this out with all the resistance readings. And when I come back, I'll show you what the results are. And through the magic of video, here are the results that I got. Now, I will tell you that one of the issues that you're going to run into is, since some of these points go through coils and or capacitors, your readings are going to be affected by the circuits. Let me give you some examples. You'll notice that pin 1 of the SA7, SK7, and SQ7 all read 1 ohm to ground. Well, let's look for pin 1. Pin 1 on this SA7 is connected directly to ground. Pin 1 of the SK7 is not shown connected to ground. Notice that it's shown as pin 1 is connected to this circle. Well, what that means is this is a shield. This is a metal tube. And so when it shows the dot there connected to this circle, what that means is that it is connected to the shield or the outside metal of the tube. SQ7, pin 1, same thing. Here it's shown connected to ground. I suspect, this is just somebody left this off the schematic, but I suspect that this is actually wired from pin 1 straight to ground, because we get exactly the same reading on all 3 of those. The second thing that I'll mention is that occasionally you'll find that, for example, take pin 3 of the 50L6. That goes through this output transformer down to these filter capacitors. These are large electrolytics. So let's look at what pin 3 of the 50L6 reads. Notice it shows infinity. What that means is that the capacitor is charging up, and if you leave the meter on this point long enough, well, unless the capacitor is leaky, and frankly at these low voltages I'd be surprised if there was any leakage in these electrolytics at the I think 1.5 or so volts that these meters apply. And so I show infinity. And the reason is that if you leave the meter on there long enough, eventually it will go to what will display as OL, which means overload. But it basically means that it is drawing so little current that it's effectively an open circuit, or infinity. So let me go over a couple of points that you do want to add to this process. One is you want to check out all of these coils. And one way to do that is by looking between different pins. For example, suppose you want to check to make sure that the primary of this IF transformer is intact. If you put one lead on the plate and another lead on the pin 4, so between pin 3 and pin 4 of the 12SA7, you are effectively putting the ohm meter across this coil. It should read very low ohms, maybe an ohm or two, maybe 3. Similarly, if you want to do the measure this, what you can do, notice that one end is connected to pin 4 of the 12SK7. The other end, you may or may not be able to tell, but it goes through this coil and eventually winds up, if I remember right, yes, on pin 8 of this 12SA7. So if you measure from pin 4 of this to pin 8 of the 12SA7, you should read the resistance of this coil. It's a good idea to check all these various coils in the radio before you try to power it up, because they're going to be needed. This is going to be needed to generate the oscillator. This is going to be needed to couple the translated signal, the intermediate frequency, and so on. Don't worry if some of this doesn't make sense to you at this point. We'll talk about this when we get there. But basically, what we have now done is prepared a chart that we can use to compare with the schematic to see if there are any surprises. I'm going to be doing that, but I won't be doing it on camera. And when next we look at this radio, I hope that any surprises that I have found, I'll be able to explain to you, and then we'll go on from there. In the meantime, have a nice day.